Hello, welcome to day 9 of trigonometry. So here's today's warm-up, and I want you to take a couple minutes to try it. We've been doing these types of questions for the last couple days. You now know 2 ways to do this question if you watched yesterday's video, so give it a shot. Right, so here's how I would do it. Whichever method you use, you've got to figure out what quadrant you're in. So tangent greater than 0 tells you that tangent is positive, and secant equals negative radical 7 over 2. Now just know that that's the same as saying cosine of theta equals what? 1 over negative radical 7 over 2, or just negative 2 over radical 7. Now I'm not going to make that simplest radical form because that's not my final answer. My final answer needs to be in simplest radical form, but that's okay to leave like that. And then this is adjacent over hypotenuse, or you can just leave it like this and think of it as hypotenuse over adjacent. But initially what's important for us is that if secant is negative, cosine is also negative. So use all students try cheating. Tangent's positive means you're going to circle what? A and T. Cosine negative means you're not going to circle A and C. Instead, you're going to circle S and T, which means you're in quadrant 3. So draw a triangle in quadrant 3. Adjacent's negative 2. Hypotenuse is radical 7. We got to find this other side. So negative 2 squared, make sure that's in parentheses, plus b squared equals radical 7 squared, which means 4, the negative goes away because it's squared, plus b squared equals 7. So b squared is 3, take the square root. B is plus or minus radical 3. This one has to be negative because it's going down. Okay, so then final answer, we wanted to find sine of theta in simplest radical form. So maybe this is where the algebra gets a little weird. Sine of theta is going to be negative radical 3 over radical 7. But we're supposed to be doing simplest radical form, so we've got to multiply top and bottom by radical 7. The top, since they're not the same radicals, you just multiply underneath them. 7 times 3 is 21 with the radical, so it's negative radical 21. And that's technically what you're doing on the bottom too. Radical 7 times radical 7, you multiply underneath, it's radical 49. But radical 49 is 7, so that's why it kind of just cancels. And that's your answer. Okay, that's probably, in my mind, the easiest way to do it. If you wanted to use the equation, and if you tried it that way, you could have, because you technically have information about cosine, and you want to find sine. So remember that formula that relates the two. Sine squared theta plus cosine squared theta equals 1. We're looking for sine. We're going to plug in negative 2 over radical 7 for cosine. So sine squared theta plus negative 2 over radical 7 squared equals 1. Which means I have sine squared theta plus, that's going to be 4/7 equals 1. And you want to think of this as 7/7. So subtract 4/7, you get sine squared theta equals 3/7. Take the square root. You can see I'm going to get the same answer. Sine of theta equals the square root of 3 over the square root of 7, plus or minus, remember, because I took a square root. Multiply top and bottom by radical 7, and I get sine of theta equals plus or minus radical 21 over 7. Now again, the downside in my mind to this situation is that I still have to use this information to figure out, okay, if I'm in the third quadrant, is sine positive or negative? It's negative. So there's my answer. All right, so your choice which way you want to go. I tend to go more towards the picture way, but it's up to you as long as you're getting the right answers. Dolphins can jump up to 20 feet in the air. Pretty impressive. All right, well today we're starting kind of the second half of this unit, which is really all about graphing trig functions. And we're going to look at sine, cosine, and tangent graphs, but today just sine and cosine. All right, so I want to start with that unit circle one more time. You've seen it a bunch already. Again, what's the key to remember about the unit circle? What's unit mean? It means that the radius equals 1. So I couldn't get this picture to work perfectly, but it's supposed to connect the circle here. So just put a big dot and say that this is randomly the point x, y. But since it's a unit circle, I want that to be 1. So what's this length down here? Again, using the point, I'm going over x and then up y. So this is x, this is y. And the purpose for that today is going to remind you that sine of theta, which is opposite over hypotenuse, is y over 1, or just the y coordinate. And cosine of theta, which is adjacent over hypotenuse, or x over 1, would just equal the x value. So on the unit circle, sine of theta equals y, cosine of theta equals x. And I know you all know that already, but I just wanted you to remember alphabetical order. X comes before y, and cosine would come before sine. And this only works on the unit circle because the hypotenuse needs to be 1. If this wasn't a unit circle, it would reduce to something that was equal to this, but it's easier to use those coordinates on the unit circle. All right, so you should be able to figure out this next section pretty easily. We've used the unit circle to evaluate trig functions of quadrantal angles. Okay, so remember this was 0, pi over 2, pi, 3 pi over 2, and 2 pi. Hopefully that's ingrained in your mind at this point. And remember what all the quadrantal points are. What's this point over here? It's 1, 0. Up here, 0, 1. Over here, negative 1, 0. And down here, 0, negative 1. Okay, so if I want to evaluate the sine of all the quadrantals, I'm just looking at the y coordinates as I go around. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is back to 0. 3 pi over 2 is back to negative 1. 2 pi back to 0. So to evaluate all these, we did the sine is equal to the y coordinate. Okay, so real quick, go through and do the same with cosine. Cosine is just equal to the x coordinate, as you know. So do the same thing, go straight around and tell me all the x values. Go ahead and list those out. Should get cosine of 0 is 1, pi over 2, that blob is 0, pi, we're down to negative 1, 3 pi over 2, back to 0, and we end 2 pi back at 1. Okay, now I wanted those on here so that we can do these graphs. So we can use these values along with the unit circle to create graphs of sine and cosine. So let's just set up the sine graph first. And I have a weird looking grid down here, but it's like that for a reason. We want to label the x-axis. If you think of this as y equals sine of x, you can see x is the angles in here, in radians. So this has to be 0. And rather than going every spot, I'm going to spread it out. So I'm going to skip a few spots. So I'm going to go every 3. So that's obviously 0 here. And then 1, 2, we're going to call this pi over 2. 1, 2, 3, call this pi. 1, 2, 3, call this 3 pi over 2. And 1, 2, 3, call this 2 pi. So I'm making an xy axis. This isn't the unit circle graph anymore. I'm not drawing angles. I'm thinking of this as a function. So the x coordinate represents an angle. So that's why these are getting spaced out here. The y coordinate What's the lowest the y value ever got? Well, if I'm on the unit circle, the lowest the y value can get is -1. So I'm going to call this spot right here -1. And similarly, if I'm on the unit circle, the highest I can get is +1. So I'm going to call that spot +1. Okay, so now just plot all these quadrantals. So we've got 0, 0. So that point there. Pi over 2, 1. Right there. 0 is pi. 3 pi over 2 is at -1. And 2 pi is back at 0. Now before you go ahead and connect these dots, here's what you can't do. Don't write this. This would be wrong. That's not what the sine graph looks like, because the values in between aren't necessarily at going up by a constant amount. And what I mean by that is this circle is kind of causing it to have a curvy shape. And let me take those green lines off. I can use this website to show you. So here, this is going to give me all of the y values. I'm doing the sine graph right now. It's going to give me all the y values between 0 and 2 pi. Right now I'm at 0 degrees, and this is in degrees, but so 0 and 360. And you can see that initially the y value is at 0, so this graph is plotted at 0. If I drag this through the first quadrant, as I go, you can see at different angle measurements, I'm always taking whatever the y value is, because this is a unit circle. So whatever the y value is what's getting plotted over here, all the way up till I get to 90 degrees, which has a y value of 1. Now as you watch this graph go around, you can see I'm always plotting the y values, but it's also going around this circle, so that's why it's got this curvy shape to it. If I go over to 180, it curves back down to 0, and then as I go past there, now these are negative values because these are negative y values over here, so that's how they're getting graphed. Down to 270, and then all the way back to 360. So it's going to have this kind of curved shape to it because I'm evaluating y coordinates as I go around the unit circle. Okay, so when you go to graph it, that's what I need to see. Not jagged mountains, but rolling hills. So this is kind of like an upward hill, and then this is a downward valley. Kind of missed that point there. Let's try it again. Yeah, like that. So that's one cycle of sine. Now the thing to remember is, and I can't really show you on this picture, is I could go around again. We could go 361, 362, all the way around to 720, and I'd have another one of those same shapes happen. So really the sine graph goes on and on in both directions forever. This is one cycle of it, and that's what we're going to look at most often. But know that, I'm just going to do kind of a dotted line, it keeps going in both directions. So this is called a periodic function because it has a regular period. It just keeps repeating. It's like a sound wave. You might have seen when you take physics. So knowing that that's what the graph really looks like, what would you say the domain of sine is? It goes left forever and right forever, because I can go as high as I want as an angle and go around that circle as many times as I want, and going this way is just negative angles, so I can go clockwise around that circle as many times as I want also. So the domain is negative infinity to infinity. But what's the range? What's the lowest it goes? -1. What's the highest it goes? 1. And does it reach those values? Yup. So those need to be brackets. Okay, let's do the same thing with y equals cosine of x. I'm going to set up my graph pretty much the same way. So this has to be 0. Go every 3. That would be pi over 2. That's pi. That's 3 pi over 2. And that's 2 pi. And just like sine, the highest cosine can be is 1, and the lowest it can be is -1. And this time I'm just plotting all the cosine values. So 1, 0, -1, 0, and 1. So it starts at 1, then goes down to 0, then goes down to -1, then goes back up to 0, and this one ends at 1. or at least that first cycle ends at 1. Okay, let me show you that. Here's the cosine in the unit circle. Now I'm taking the x value. So when I'm at 0 degrees, my x value is up at 1. So that's why I'm up at 1. As I go through the first quadrant, you can see that all these triangles on the unit circle now they're taking the x coordinate, so this length, and plotting that as the height here. So as I get up to 1, now my cosine value is at 90 degrees is 0. As I go around here, these are negative x values, which is why I'm below the x-axis to negative 1 to 180. Once I go past 180, I get closer and closer to an x value of 0 again. And then after that, now my x values are positive because I'm on the right again, all the way to 360. So it's got that curvy shape just like sine did because it is going around the circle, so not jagged. Okay, so go ahead and plot this. But again, you've got to make kind of a rolling shape as opposed to a jagged shape. And just like sine, I can go around the unit circle as many times as I want in the positive or negative direction, but it's always going to bounce between -1 and +1. So my domain is still negative infinity to infinity, and my range is still bracket -1 to 1. Okay, so those are the graphs, and you're going to need to memorize what these look like. Okay, next page. Now I want to show you how this connects to stuff you already know. So now we can use the unit circle or these graphs to evaluate quadrantal angles. So if I asked you to do sine of 270, you absolutely can use the unit circle and say that 270 is down here, and this point is 0, -1. Sine is the y value, so your answer is -1. Totally fine. But now you can also use this graph. And this is what some people prefer. So if this is 0, 90, 180, 270, and 360, going from 1 and -1, sine starts at 0. And I know this again just because I've memorized this graph, but this is what the graph looks like from the previous page. So if I'm looking for sine of 270, here's 270, and I look at the value of the graph, it's -1. Cosine of 90, same idea. I can absolutely use the unit circle. 90 is up here, and this is the point 0, 1, and I know cosine is the x value, so my answer is 0. Or I can think of the cosine graph. There's 0, 90, 180, 270, 360, 1 and -1. What I just showed you is the cosine graph starts at 1, and it goes all the way down to -1, ends back up at +1. So if I wanted to find cosine of 90 and I knew the graph, there's 90, and you can see I'm right at a value of 0. Now cosine of -5 pi over 2 might be a little bit trickier. I would probably use the unit circle in that case because the typical cycle doesn't have -5 pi over 2 on it. I could figure it out by going this way, but use whatever's easiest. So -5 pi over 2, this is 0, -pi over 2, -pi, -3 pi over 2, -4 pi over 2, this would be -5 pi over 2. 0, -1, it's cosine, so the answer is 0. Okay? All right. Now, they also confirm what we already knew about what we've been looking at the last couple days. All students try cheating. This is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Let's look at the graphs and see how that tells us what we already know. Here's the sine graph. 0, pi over 2, pi, 3 pi over 2, 2 pi, 1 and -1. Okay, now start picturing the graph. Where does sine start? Sine starts at 0. That's one with the hill, so it goes up to 1, back to 0, and the valley, down to -1, back to 0. Okay, now look at where the quadrants are in this graph. 0 to pi over 2, right here, that's quadrant 1. Pi over 2 to pi, that's quadrant 2. Pi to 3 pi over 2, there's quadrant 3. And finally, 3 pi over 2 to 2 pi, there's quadrant 4. Now, what do you notice between 0 and pi? The sine graph is above the x-axis. So that means the values of sine from 0 to pi are positive. And from pi to 3 pi to 2 pi, the values of sine go below the x-axis. So down here, the values of sine are negative because those values are negative values. Isn't that just what we know from All Students Try Cheating? Where is sine positive? Quadrants 1 and 2. That's what the graph is telling me. Quadrants 1 and 2, between 0 and pi, sine is positive. Where is it negative? Quadrants 3 and 4, again, confirmed by the graph. Let's try it with cosine. 0, pi over 2, pi, 3 pi over 2, 2 pi. Here's 1, here's -1. Cosine is the one that starts up at 1, goes all the way down at the middle to pi, and then gets back up to +1 again. 0 to pi over 2 is quadrant 1. Pi over 2 to pi is quadrant 2. Pi to 3 pi over 2 is quadrant 3. And 3 pi over 2 to 2 pi is quadrant 4. So it's important to note the difference here. When I go around and label it, and that's why I have you label 0, pi over 2, pi, 3 pi over 2, 2 pi, we're using the axes here as a means to draw angles, not the regular x and y's. This is the regular Cartesian, it's called XY graph. It's taking this graph and spreading it out. People get confused because these are different. So here, you can see cosine's positive between 0 and pi over 2. And again at the end, from 3 pi over 2 to 2 pi. That's when the cosine graph goes above the x-axis. In the middle, cosine is negative, between pi over 2 and 3 pi over 2. And that's exactly what All Students Try Cheating tells us. Where's cosine positive? Quadrants 1 and 4, between 0 and pi over 2, 3 pi over 2, and 2 pi. Where's it negative? 2 and 3 in the middle. Okay, so I just wanted to show you that because it really is just giving us the same information in a different way. Okay, the last part of the notes today, we're going to be looking at how to move these graphs. These graphs can be used to show a lot of different real-life applications, and that's going to be our goal in the next few days. But it all relates back to transformations. There's some new trig vocabulary that we're going to use instead of what we're used to with transformations. So here's kind of our parent functions. Parent functions are y equals sine of x and y equals cosine of x. I can translate them and shift them and dilate them by putting different numbers in different places, just like you did earlier in the year. So a, that number out front, when you put a number out front multiplied by an equation, what was that called? That was called a vertical stretch or a dilation. This is a vertical stretch or shrink, depending on what the value is. And if you'd rather think of it as dilation, you can. And we also had an extra thing. If that a was negative, what happened to the graph? The reflection, but a reflection in which axis? In the x-axis. And that's still the same in trig. It's still going to affect the graph that way. But ignoring the reflection for a minute, so if I just say the absolute value of a instead of a, the absolute value of a is called the amplitude. And the definition is basically the vertical stretch. Now, since I made that the absolute value, this is always positive. So I'm not talking about the reflection if there is one when I'm talking about amplitude. I'm just talking about the stretch or the dilation. And another way to find that, if you're given a graph, is to take the maximum value minus the minimum value divided by 2. So if I take max minus min divided by 2, that's how high it rises and how low it goes. That's called the amplitude. Now B, we haven't done in a few months. That's a horizontal stretch or shrink. It was kind of annoying back when we did it in Unit 2. In trig, that B value is called the frequency. In frequency, we're going to go over these later and you'll see what they mean more. But for now, I'm just going to call that the number of cycles between 0 and 2 pi. And I'll show you this on the sine and cosine graphs in a second to make it make more sense. Okay, what's C do? Well, when I'm in with the x, I go left and right. And this is the backwards one. If it's plus C, I go left. If it's minus C, I go right. So this is a translate left if plus C and right if minus C. Same exact thing with trig functions. The fancy word they give to it is phase shift. So a phase is like a cycle, so where the cycle shifts to, left or right. And finally, what's that D do on the end? It's going to translate it up and down. And that one's more normal. It translates it up if plus D, down if minus D. In trig, instead of translating up and down, we call that the midline. And the midline is y equals whatever that D value is. And you can think of midline as splits graph in half horizontally. Okay, so you can see they do the exact same thing. I'm just giving some new vocab with it. And we're going to really delve into what these are in the next few lessons. Now, period is one other word that you're going to see come up. That's the length of one cycle of the graph. And it turns out that period, and I'll show you where this formula comes from in a couple days, is 2 pi divided by whatever that B value is. So remember, B was this number in front of the X here. That's what period is. 2 pi divided by B. Okay, so I just want to end with looking at the sine and cosine graph one more time and applying all of these terms to it. So here's one cycle of sine in red, and it goes on and on forever, which is why it keeps going like that. You can even put arrows on the end of these if you want. But let's talk about what all these are. Now again, I'm just going to write y equals a sine of b x plus c plus d, just so you have it to reference to. Amplitude, I said, was the absolute value of a. So for y equals sine of x, what number's out front here? You can always think of it as 1 sine of x. So the amplitude for the sine graph is 1. The other way I told you to find it was to do max minus min divided by 2. What's the maximum of the sine graph? 1. What's the minimum? What's down here? -1 divided by 2. 1 minus -1 is like plus positive, so that's 2 over 2. You can see I get 1. Frequency. That was always b. And b is the number that's in front of the x. So what number's here? Also 1. And again, frequency means number of cycles between 0 and 2 pi. So between 0 and 2 pi, going up, coming down, and running back at 0 repeats after that, but that's what one cycle of sine is. So that's why the frequency, the number of cycles between 0 and 2 pi, is 1. Phase shift is this c value. What's being added next to the x? Nothing. So c is 0. And you can think of the phase shift as the x value where the cycle starts. And I put start in quotes because it's hard to say where it starts since it goes on forever in both directions. But here's my first cycle, and it starts at an x value of 0. Midline, I said it's y equals d. D is the thing added on to the end, which is nothing here. So it's y equals 0. Again, you can also do max plus min divided by 2 for that. Did I say that on the last page? I didn't. So you might want to flip back. This is max plus min divided by 2 always. So similar to amplitude. But amplitude's max minus min, this is max plus min. Okay, so if I do 1 plus negative 1 divided by 2, that's how I get 0. And the midline is just kind of an imaginary line that splits the graph in half. So half the cycles above it, half the cycles below it. And finally, the period, I said that was that last equation, 2 pi over b. Again, what's b here? B is the number in front of x, so that's 1. 2 pi over 1, I get 2 pi. And that is the length of one cycle. One cycle takes between 0 and 2 pi. So think of this as the length of one cycle. So if I take the end of a cycle minus the start of it, you can see it that way also. The end of this cycle happens at 2 pi. The beginning of this cycle starts at 0. 2 pi minus 0 is 2 pi. It's the length of the cycle. Okay, so that's what all those terms mean when applied to sine. What do you think they're going to be for cosine? Right, very similar. Amplitude, absolute value of A, is 1 again. And you can also look at that from the midline. It goes up 1, down negative 1. Frequency, the number in front of the x, the B value, is also 1. Phase shift, the C value, there's no plus C here, so that's 0. And the cycle starts at x equals 0, so that's why that's 0. Midline is the D value, the number added onto the end. Since D equals 0, that means the midline is the equation y equals 0, because that splits the graph in half. The period, you can see in red again, one cycle happens between 0 and 2 pi. So period 2 pi over b. Again, b is 1 because the number in front of the x is 1. You get 2 pi. And once we start transforming graphs, these numbers are obviously going to change. But on the parent functions, those are the values of all of those. All right, so there's your intro to the trig graphs. You are now ready to do tonight's homework. So good luck with that. Let me know if you got any problems. See you tomorrow.